In this last video, we're going to step back and look at the big picture and look at all the key topics that we talked about in this section. And so in the first video, we talked about what a limit was. And really what we're doing when we're evaluating a limit is we're trying to determine the behavior of the graph at that value of x. So if we look at the graph and we answer these questions comparing it to the graph, the first question is asking about the behavior of the graph at x is equal to -4. So we have the one-sided limit, then the two-sided limit, and then the value of the function. So as I look at the graph and I approach -4 from the left, it looks like we're approaching a function value of 0. When I approach -4 from the right, we're approaching a value of the function as 0. Now, because the one-sided limits are the same, that means the two-sided limit is going to exist, because coming from both directions, the two-sided limit will be 0. Now, if I look for the value of the function at -4, when x is -4, I can clearly see from the graph that the value of y is 0. Okay, in the next example, we're looking at the behavior of the graph around -2. So as I approach -2, I'm doing this one in purple, coming from the left, it looks like I'm approaching a y value of 3. Coming from the right, it also looks like I'm approaching a y value of 3. And because the two one-sided limits are the same, that means the two-sided limit will also be 3, because coming from both directions, from both sides, the limit is 3. Now, the value of the function at x equals -2 does not exist. There is an open circle at on the graph at x is equal to -2, which indicates to me that there's a hole in the graph and a missing value there. So there is no -2 in our domain for this function. Looking at the next line, we want to look at the behavior of the graph around 1. If I approach 1 from the left, it looks like I'm approaching y value of 6. Approaching 1 from the right, it looks like I'm approaching a y value of 3. Now, because the one-sided limits are different, the two-sided limit is not going to exist, because it's coming from two different sides. There's going to be two different values. Okay, now the value of the function at 1, if I look at x is equal to 1, there's an open hole at y is equal to 3. So the value doesn't exist at the point 1, 3, but it does exist at the point 1, 6. So my value at x equals 1 for the function would be 6. All right, last example. We're looking at the behavior of the graph at x equals 3. And if you notice, even though it's not written in there, we can visualize that there is a vertical asymptote at x equals 3. If I approach the graph, if I approach x equals 3 from the left, I'm decreasing without bound. So my one-sided limit as x approaches 3 from the left is going to be -infinity. Coming from the right, as I approach x equals 3, I'm also decreasing without bound. So that's also going to be -infinity. Because the two one-sided limits are the same, I can say that the two-sided limit is also -infinity. Doesn't matter which direction you're coming in from, your limit as you approach x is 3 is going down. You're going to -infinity. Now, because there's an asymptote there at x is equal to 3, there's no value of the function, so we would say that this does not exist. There's no value of the function at